Now we talk about expectation of a joint function. So say you have two random variables, capital X and capital Y, and then you have a function g which takes in the input as the random variables x and y. So expectation of this joint function gxy is you go from minus infinity to infinity dy, that is y goes from minus infinity to infinity, and then you have x going from minus infinity to infinity, you have dx. So you just take g x comma y and multiply it with f of x comma y. So f is the joint density function of random variable x and y. So in particular, say you have g of x comma y as a of x plus b of y, and then you can take the expectation of gxy. It will come out to be a times expectation of x plus b times expectation of y. So basically you will plug this in this formula here, and then you will use marginal densities, and that will give you this result. So we are not going into details, but you can find the details in a text on mathematical statistics. So just like two variable case, so we have two variable case x and y, you could have n variable case. So we can have a joint distribution function for n random variables. In this case, you get expectation of a1 times x1 plus a2 times x2 all the way to an times xn is a1 times expectation of x1 plus a2 times expectation of x2 all the way to an times expectation of xn. Notice that this ai is a constant. So that is a1 is a constant, a2 is a constant, all the way to an is a constant. So let us do some examples to make this concept more clear. So the first example is, say x is the sum of outcome of roll of 5 fair die. So x is sum of these outcomes of roll of 5 dice, x1 plus x2 plus x3 plus x4 plus x5. So expectation of x is expectation of these roll of the die, and expectation of each roll of die is 7 by 2. This is also 7 by 2, 7 by 2, because these are identically the same 5 dice. So this will give you 5 times 7 by 2, which is 35 by 2. So notice that on the roll of a die, your expected value is 7 by 2. So in case you have forgotten, this is just comes from 1 by 6 of 1 plus 2 plus 3 plus 4 plus 5 plus 6, and this will be 7 by 2. So another example, x is the sum of N Bernoulli trials. So x is equal to x1 plus x2 all the way to xn. Now this is nothing but the binomial random variable with the parameters n, where n is the number of trials and p is the probability of success. So here you have expectation of a single Bernoulli trial is p, and remember this comes from the idea that you have 0 times 1 minus p plus 1 times p, because the Bernoulli trial takes only two values, 0 and 1. 0 is failure, 1 is success. Probability of 0 is 1 minus p, probability of success is p. So this is the expectation. Now you take the expectation here, you get expectation of x1 plus expectation of x2 plus expectation of x3 all the way to plus expectation of xn. So this is equal to n times p. So you have p plus p plus p plus p all the way here, n times, you have n times p. Now notice that this derivation is for expectation of a binomial random variable with parameters n and p. So notice that previously we had written a complicated derivation for calculating the expectation of a binomial random variable. Here it is so much simpler. It is just adding p n times.